Welcome to my YouTube channel Mechanical Magic Mechanical Learning Tutorials. Today we will be discussing boiler mountings and boiler accessories. Boiler mountings. These are different fittings and devices which are necessary for the operation and safety of a boiler. Normally these devices are mounted over the boiler cell. According to the IBR Indian Boiler Regulation, the following mounting should be fitted to the boilers: two safety valves, two water level indicators, a pressure gauge, a steam stop valve, a fit check valve, a blow off cock, mud holes, or you can say the side holes, a manhole, an attachment for inspector's test gauge. Some of the boiler accessories: these auxiliary plants or parts required for steam boilers for their proper operation and increase the efficiency of the boiler. Commonly used boiler accessories are as feed pumps, injectors, economizer, air preheater, superheater, steam separator, and finally steam strap. Let us start with the different boiler mountings. Here is the Bourdon tube gauge. Start with the pressure gauge. Function: it is an instrument measure the pressure of steam in boiler. Construction: the gauge is usually mounted on the front top of the cell or drum. It is designed to read pressure in kgA per centimeter square or bar above the atmosphere. The circular band Bourdon tube of oval cross section is closed at the end and the other end is connected with steam space of boiler through the siphon, or you can say the U-shaped tube. Working: when pressure is applied to inside the oval tube, its cross-sectional tend to become circular and the free end of the tube try to become straight, so turning the spindle and needle by the links and gearing mechanism as shown into the figure. Water level indicators. Function: it is incline the water level inside the boiler to an observer. Working of the water level indicator: the water of the boiler comes into the glass tube through the lower tube and the stream through the upper tube. The water then stands in the glass tube at the same level as in the boiler. Two cocks are used to control the passage of between the boiler and the glass tube, while the third cock is in use to discharge the sum of the water from inside the boiler to see whether the gauge is in proper order or not. Steam stop valve. So many components will be fitted for stopping of the leakage and controlling of the outgoing steams. So let us start with the function: to regulate the flow of steam from the boiler to the steam pipe or from one steam pipe to the other. Construction: the flange of valve body bolted to the boiler at the highest part of the steam space. It consists of valve seats and nuts. The main body of valve is made of cast iron and valve seat made from gun metals. When steam stop valve is placed directly over the boiler and connected to the steam pipe line is called as a junction valve. If it is placed near to the prime mover, then normally called steam stop valve. Working: the spindle is rotated by the help of the hand wheels. Due to the rotation of the spindle, the valve moves up and down. When the valve sits over the valve seat, the passage of steam is completely closed. The steam passage may be partially or fully opened by move the valve up help of the rotating the hand wheels. Fit check valve. Start with the function. It is used to control the supply of water to the boiler and to prevent the escaping of the water from the boiler when the pump pressure is less or pump is stopped. Construction: the fit check valve is fitted in the water space of the boiler just below the normal level of the water. It consists of non-return valve, water inlet pipe, water outlet pipe, spindle, gland and handwheel. Outlet pipe of the valve connected with the boiler and inlet pipe connected with the end of the delivery pipe of the feed pump. Working. Inlet and outlet pipe of the valve is exposed different pressure. At inlet of valve and the feed pump pressure acts and outlet pipe of valve of the boiler pressure act. When feed pump is in operation, the pressure of the feed pump side inlet is more than the pressure on the boiler outside. This pressure difference lifts the non-brittle valve and allows water flow into the boiler. Next, blow-up cork function. The blow-up cork or valve performs the two functions. First, to discharge periodically a portion of water which contains mud, scales or sediments at bottom of boiler vessels while boiler is in operations. Second, to empty the boiler when necessary for cleaning, inspection and repair. As from the figure shows the working of blow-up cork, in order to operate the valve, the rectangular slot is brought in line with the passage of the body. This is possible by rotating the plug with the help of wheel. When the slot is placed in these positions, the cork is opened and all the impurities, mud, sediments, etc. are flowing out of the boiler and they are removed. When the slot is brought at right angles to the passage of the body, the cork is closed. Next, fusible plug. Its function is to protect the boiler against the damage due to the overheating. For low water level, it is fitted in the crown of the furnace or firebox at appropriate places. Working. In the normal working condition of the boiler, the fusible plug is fully submerged under the water. When the water level falls below the fusible plug, the plug gets uncovered from the water. The upper portion of the plugs get exposed to the steam space. Safety valves function. To release the excess steam when the pressure of the steam inside the boiler increases higher than the safe pressure. The safety valves are used to maintain the safe pressure inside the boiler. As soon as pressure of the steam inside the boiler increases higher than the safe pressure, the safety valve automatically opens and excess steam rushes out into the atmosphere. Still, pressure drops down to the normal value. Safety valve is generally mounted on the top of the cell. All boilers should have at least two safety valves. Safety valves may be classified as deadweight safety valves, lever safety valves, spring-loaded safety valves, high steam and low water safety valves. Deadweight safety valves, as shown in the figure. Construction: a valve is placed upon a valve seat which is fixed upon a long vertical pipe having a flange at the bottom for fixing at the top of the boiler. The weight carries suspended from the top of the valve which carries cast iron rings or weights. The total weight must be sufficient to keep the valve on its seat against the normal working pressure. Working. When the steam pressure exceeds the normal limits, this high pressure steam creates upward force on the valve. The valve lifts with its weights and the excess steam escapes through the pipe of the outside. Some of the advantages. The construction of the valve is simple. It gives satisfactory operations for low pressure and stationary boilers. Disadvantages. It is not suitable for moving boilers as the force of the weight should be always vertically downward direction. It is not suitable for high pressure boiler as the weight becomes too large. High steam and low water safety valves. Function of this valve. The steam automatically escapes out when the level of the water falls below the normal level. It automatically discharges the excess steam when the pressure of the steam arises above the normal pressure. Construction. This is a device which combination of two valves and serves two purposes. It consists of the valve V resting onto the valve seat and valve U hemispherical valve loaded with the weights resting onto the valve V as shown in the figure. Inside the boiler, a lever L1 is hinged at the fulcrum. One end of the L2 lever attached to a float E and carries the weight W. Working. When steam pressure rises above the normal pressure of the boiler, the valve V lifted along with the valve U and excess steam escapes out. When the water level is fall below the predetermined value, float moves upward and valve U is moved up. This will provide the special passage to the steam for the whistling. Lever safety valve construction. It consists of the block on which the valve seat is screwed and valve is raised onto the valve seat. One end of the lever is hinged and the other end carries a weight. Here downward force on valve is transmitted through the strut. The lever raised onto the bridge which is fixed to the block. One end of the lever, a weight is attached and other end is hinged. The required weight is determined to keep the valve close up to the designed steam pressure. Working. When the pressure exceeds the normal limits, the upward force of the valve is become higher than the downward thrust on valve due to the weight W on the lever. Thus, the valve lifted from its seat with its weight and excess steam will be come out of the boiler. This safety valve is used for stationary boilers. It is used as a pressure higher than the dead weight safety valves. Spring loaded safety valve construction. It consists of the cast iron body having a two branch pipe. Two separate valve V are placed over the valve seat as shown in the figure. A lever is placed over the valve by means of two pivots. The lever is held tight at its proper positions by means of the springs. One end of the spring is connected with the lever while other end with the body of the valve. The valve is kept on its seat with the help of the spring force. Working. In normal conditions, the downward force due to the spring is higher than the upward force applied by the steam. The valve is closed due to the spring force. When steam pressure exceeded normal limit, upward force due to the steam pressure is become higher than the downward force due to the spring. Thus, the valves are lifted from their seats, opening the passage for the steam to release out to the boiler. The spring-loaded safety valve is used to stationary boiler as well as the mobile boiler, and the boiler operation is not affected by the vibrations and jerks. Now starting with the boiler accessories. So feed pump, injectors, economizer, air preheater, superheater, steam separator, steam trap. Feed pumps function. The feed pump is a pump in which used to deliver feed water to the boiler. Double feed pump is commonly employed for the medium-sized boiler. Types of the feed pumps: reciprocating pumps, simplex, duplex, triplex, rotary pumps, centrifugal pumps. Steam boiler generally use reciprocating duplex type of pump. So as shown into the figure, reciprocating duplex pumps. The duplex pumps is very commonly steam-driven reciprocating pump. It consists of the steam cylinder and the water cylinders are placed side by side. There are two steam pods for each of the steam cylinders. Pistons of steam and water cylinder are connected by connecting rod and a drive for carrying out the reciprocating movements of the piston. Injectors. Two types of injector is being used: water injector and fuel injector. Economizer. As from the figure shows that function of the economizer to increase the temperature of the feed water using the waste of the heat to flue gases leaving the boiler through the chimney. So you can recover the heat from the wasted gases to increase the inlet temperature of the water with this diagram. Construction and working. Economizer consists of the large number of vertical cast iron or steel water pipes located between the two horizontal pipes. Feed water enters into the economizer through the bottom pipe. From the bottom pipe, water is come into the top pipes through the vertical pipes and then comes into the boiler. The hot flue gases passes over the vertical tubes and heat transfer takes place from the flue gases to cold water in vertical tubes. During that shut of the flue gases are deposited onto the outer surface of the vertical tubes, which reduces the efficiency of the economizer. To prevent the soot depositions, strappers are provided which moves up and down by chain gear arrangement to clean the vertical tubes. Air preheater. The function of the air preheater increase the temperature of the air before it supplied to the furnace using heat from flue gases before passing through the chimney. So as shown into the figure, construction and working, an air preheater is installed between the economizer and the chimney. It consists of the large number of tubes which arrange in the part of the flue gases cell, and hot gases pass through the tubes. Hot flue gases enters into the tubes from the top of the cell and leaves from the bottom to the chimney. The inlet air at room temperature is admitted into the cell and the lower end with the help of the fan. The air passes around the tubes in the opposition directions to the flow of hot gases. Buffels are provided inside the air preheater, this increasing the total path length of air, thus increasing the heat transfer. Soot hoppers are provided to collect the soot during the cleaning operation of the tubes. Superheater. As shown into the figure, the function of the superheater is to increase the temperature of the steam above its saturation points. As from the figure, construction and working, this superheater consists of a set of superheated tubes in the form of U-tubes and two headers. The set of U-tube is connected with the mainstream pipeline through the headers, and U-tube placed in the part of the flue gases. The amount of hot gases passes over the superheated tubes should be in a proportion to steam passing through the tubes and degree of superheat required. The degree of superheat is controlled by the dampers with the help of hand wheels. When valve V1 and V2 are open and valve V3 is closed, the steam passing through the superheater is in action. But when the superheating is not required, the valve V1 and V2 closed and valve V3 is open. The steam is passes from the boiler drum to mainstream pipeline. No superheating take place. Steam separators. As shown from the figure, the function of the steam separator, it removes the suspended water particles from the steam. From the figure, construction and working, it consists of inlet and outlet steam pipes, baffles, and water drain cocks. The steam enters at the inlet pipe A and flows down. In its passage, it strikes with the baffles. As a result, it gets reflected, but the water particles having a greater density and inertia fall to bottom to the separator. The dry steam moves up and discharged through the outlet pipe B. The water collected at the bottom of the separator is drained out of a cock C periodically. A water gauge glass indicator the level of the water into the separator. And last, steam trap. The function is steam trap is a device used to discharge the condensed steam or condensed water with a negligible consumption or loss of live streams. As from the figure, construction and working, it consists of the bucket casing with inlet outlet tube D, guide pipe P. The end of the spindle is fitted with the bucket at the center and the other end works at the valve. A guide pipe is fitted inside the water chamber which has an outlet at its top. This outlet opened or closed by the valve which moves downward and upward with the spindle. At normal conditions, bucket floats over the water and outlet is closed by the valve. When sufficient water is collected into the water chamber, then enters into the bucket by overflow, and weight of the water causes the bucket to come downward with the spindle, providing thereby an opening of the outlet. So thank you very much. If you like, my channel. Subscribe, like, share mechanical magic, mechanical learning tutorials. Thank you very much.